Hello. Today I'd like to talk to you about the Arctic. Two things you should know about the Arctic. First, it's cold. But second, and more importantly, it's getting warmer. Specifically, in the next 100 years, we're thinking that it might warm by as much as 15 degrees Fahrenheit on average. That's going to change a lot of things. For example, the soil that's frozen underneath the land surface in the Arctic. There are hundreds and hundreds of feet of frozen soil underneath the ground in the Arctic. As it warms, a lot of that frozen soil might thaw a little bit. And that frozen soil has carbon. Now, why is carbon important? Well, the things that make up greenhouse gases are made up of carbon. And so if we unlock that carbon from its prison of frozen ice, if we thaw that ice and the carbon is allowed to move around, well, we're going to get more greenhouse gases in our atmosphere, and we might see the Earth get even warmer. Carbon doesn't move on its own. It's carried by water. Think of water as the bus, and carbon as the people that get on the bus and go down to wherever they're going. If you have more buses, you're able to move more people. So my research involves that specific relationship. We have never really looked at how many buses there are in the Arctic, so how much carbon those buses can transport is something that we do not yet know. Let's keep thinking of this idea that water is a bus that carries stuff. Only instead of carbon this time, the stuff that makes our atmosphere warmer, water is going to carry energy. By that I mean heat. And so I want to see what happens when I bring this bus in contact with some solid ice. We'll see the effect of water on this ice by taking two identical balls of ice. I just took them out of the freezer at the exact same time. I'm going to run liquid water over one of them right here, and then I'm going to let the other one just sit out, and we'll see what happens. Let's see the results. No water at all, and the ball is still pretty much the same as it was before. With liquid water, you can see that the ice has carved a channel into, or the water has carved a channel into this ice ball, making it look a little different and melting a whole lot faster. So what does this all mean? Well, there are potentially two different ways for ice to melt. We've only studied one in depth, but the second may also be critical. And so my research is to go out, measure where water levels are, measure where ice is, and measure how warm the atmosphere is, and try and determine from these measurements and from computer models that I'll build how important this is in the overall warming of our Earth.